have Jim Heck and Ciaran Morgan. Jim, of course, is the Secretary of AMSAT-UK, but also the project manager for FUNcube. And I must say, one of the reasons it seems to be working reasonably well is because Jim spent days and days and days and days checking all the software did what it was supposed to. And thank you very much for doing that, Jim. I gather Ciaran will be along a little later. Ciaran's involved in some of the educational outreach we're trying to do with FUNcube. But I'm sure all that will become fairly clear over the next 45 minutes. So with drink in hand and hopefully microphone working, I'll hand over to Jim.
Thank you very much. David? I wasn't the only one doing the software testing. I was making the coffee. It's got to be here somewhere. This way. Okay. I'm not going to try and give you a lot of technical detail about FUNcube or FUNcube-1. I'm not a technical person. I enjoy technicality, but there are much better people than I around and clever and everything. But I want to try and give you a little bit of the flavour and the atmosphere, and a few facts of the launch and the build-up of the launch, and thereafter. Get the right page for my notes here. The thing was launched on a Dnepr rocket, which is an ICBM. Or converted ICBM. We had an interesting experience where we went down to give a presentation to some school children at Goon and we said ICBM and they didn't know what it was. And they were about 17, 18, and I thought, that's interesting. There's a generation gap for you, so made me feel older still. Here's again just a picture of the team. I'm just going to take just a couple of minutes just to sort of introduce them to you, because I think it's important well, it's not important, you know, but you might be interested. First of all, missing on the bottom left was a chap called Gerard Albers, who was doing a lot of software configuration and testing. During the project, he announced his engagement. Bear in mind, this started about 4 years ago. The other guy is Ciaran Morgan, who's going to be speaking after me about the outreach aspects of FUNcube. He's M0XTD and was largely doing outreach later on in the project. He also does, a matter of interest, a lot of work with ARIS. Then starting front row, bottom right is Howard Long, who needs no introduction really. He was quite strange. When we started off, we were trying to split the jobs up, and one of the things we wanted to do was a ground station. And Howard said, "I'll do the ground station." And we talked about it a bit in very general terms, and then he went quiet for about 18 months, and we sort of wondered, where is he? You know, has he lost interest? And then he popped up, and he said, "Finished." And the FUNcube dongle was there. It was fantastic. And as you know, he's done a pro version. The guy sitting next to middle in the front row is Wouter Wegler, who most of you know, he's at the back, and G3WGM. He did the design of the RF board, and he was in a unique position because not only is he a member of AMSAT-UK, he also started off AMSAT-NL, and is also an employee of ISIS, who was our sort of commercial partner, if you like. And we did pay them some money. I don't think we paid them as much as perhaps they gave us. But he, as an employee, he always had to indicate which hat he was wearing, whether it was his AMSAT hat or his employee hat. And when a group of us would go to ISIS, which he did quite a lot, to use their clean room, particularly later on, their clean room and a lot of their test gear, it was Wouter who was sort of meeting us at the front door and letting us in. The next guy is a guy called Jason Flynn, on your left in the front row. Jason's G3WGM. A lot of the microwave people will know him. Path design called for a thing called a CPLD, and I can't understand what that. I can't remember what it stands for, but it's something logic array. And I thought, I must get into logic arrays, and I got a few books and papers and stuff, and gave up. They're extremely complicated, extremely difficult to. Not difficult, but they are complicated, and I guess they're difficult to understand how to program. And Jason did that. And I recall on one occasion we were in ISIS in Holland, and we just thought, we're not certain about this CPLD software. And Jason owns a boat, and he was on his boat on the East Coast, so we phoned him up on his mobile, and we said, Jason, could you just check this bit of the CPLD code? He said, yeah, okay. He just sort of took a reef in and got his laptop out, and phoned us back in about a quarter of an hour, and he said, yeah, I got a new image for you, and emailed it to us, and there we were back on the road. It was fantastic. So going along the top now, on the right is, on your right is David Bowman, G0MRF. His main contribution was the design and building of the PA board, and David is a retired. You call yourself a school technician, David, or what's your official title? I know I'm not quite certain.
I'm down to 1 day a week doing that now, science technician.
Science technician, okay. And that's great because David gave us was able not only to do the PA board design, but also a little bit of, well, if you do it this way, guys, schools won't like it, sort of thing. Next to him is a chap called Phil Ashby, who is now M6IPX, has been licensed for about 2 months. He was part of the team doing the flight software and also the dashboard, and he works at Martlesham along with Jason at the Martlesham BT research place. Next on the list is David Johnson, G4DPZ. He works for a company called Black Pepper. Is married and likes going on canals, like canal boats, and he did the warehouse software. And he came along 3 years ago and said, I think we ought to have this warehouse thing. And of course, it's absolutely amazing. It works very, very well. He's still putting bits and bobs on it and developing it, but it's a fantastic tool. Next is Graham Sherville, middle of the back, G3WGM, who probably needs no introduction. He was one of the very original people and largely put the team together. And we gave him the title of technical manager. We thought that would be a suitable title. So he had that particular job and title. He actually is I don't know whether you're a director or quite what, of a big company called Allgood. So he's very much sharing his time between his hobby and his work. The next guy is Carlos. Carlos was our pet Labrador at. Or Labrador-like person, getting in all the photographs. He wasn't actually a member of the team, but he was at Bletchley Park because he knew the layout and helped us with the layout. And he sort of got in on the champagne and the photograph, and he's very welcome. The next guy is a guy called Duncan Hills, M0XTD, recent call sign. He's the third guy who works at BT Martlesham, and was again flight software. And also the dashboard. And of course the flight software it's not the most important, but it's one of the things that has to be right. And he was very patient, along with the other two software guys, getting it absolutely right. I did a lot of work on the dashboard, and still is. He has 2 young children, which are another call on his time, and sometimes so I can't quite finish this software package. I've got to go and play football with my son, who I think is about 6. And there's a lovely picture of his daughter soldering up one of these quadrifilar antennas. So he had a great fun. And last but not least, me. And I just wanted to be involved in this. And at the beginning, I said, look, I'll be the project manager, whatever that means. Sometimes I feel I was a sort of chief cajoler or coordinator, or call it what you like, but it's been a huge privilege and joy to sort of link all this gang of people up. There were other people who helped. Some dipped their toes in, didn't like it. One or two came in and I think had other calls on their time. But they certainly are the gang who's done the majority of the work. I'm going to show you a little video which was actually taken a year ago. It's only about 30 seconds. But it's important, it's not important you realise, but one of the features of this, of the launch, was the boot-up sequence. And we spent a long, long time considering this. And those of you who are experienced satellite people will recognise some of these. But that is the sequence that we chose for when the thing is ejected from the rocket and the little microswitch pings and the MCU microcontroller boots up. And it does go through those stages. Is the internal software flag set? You are in space, or are you still on the ground? If you're in space, is the apply before flight plug fitted? Yes, it is. Are the antennas undeployed? Yes. Then what do you do next? You wait 10 minutes. And you wait 10 minutes so you're drifting apart from the other satellites. And then you deploy the antennas. And if you get that sequence wrong, then that's mission failure because you can't deploy antennas. So if you forget to set the software flag or you fit incorrectly the apply before flight plug, your mission lost. So it was fairly sort of critical. We didn't have many chances to do this because deploying the antennas is relatively easy, but putting them back in is a sort of day's task. So we had one opportunity to do this, and I'll show you the result just now. No. Okay, well, it's easy if I do the videos outside of PowerPoint because this is a video of about a year ago. Wouter is in the clean room in Holland in a place called Delft and doing all the work, and I'm sort of doing the timing and stuff via Skype sitting in my house. Oh. And you hear a countdown. We've already waited the 10 minutes, and the countdown is to the 10-minute point.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go!
Antennas are deploying, Jim.
I think we have a decollage.
Yes, sir. It works.
Yeah, well, that's enough of that. And you see, we were pretty pleased. And as I say, that's the only time we tested the antenna deployment. That system we're using is a system called, or we call it ANTS. It's a bought-in component from ISIS, and it's been used quite a lot of times. But we felt we ought to. Okay. The next one is is what we called the pod stuffing, and this was about last June or July. Myself, Graham, and Wouter met up again in the ISIS clean room, and this is where we're saying goodbye to the baby, and it's being put in the pod along with its neighbours, ready for flight. So we've already done the final testing. We've set all the various things we need to set, like that little software flag. And first of all, there's no commentary on, there's no sound on this, so I can just talk over it. And this is us looking through the window of the clean room. This guy on the right here, Mikhail, was the guy who went actually to Yasny and was supervising the loading. And first you'll see ZA-Cube go in. You can tell by the flag. And everything's done very carefully, very deliberately, and very closely inspected to make certain everything's right. Particularly coming into view now is this screwdriver here, which is holding back the spring of the pod. Is it a screwdriver or a special tool, Wouter? Screwdriver, okay. Thanks. So in goes ZA-Cube, And bearing in mind that that team will have been doing the same amount of work of us over a number of years, and so they want to get it right. This is now Wouter going to put FUNcube in. And I think he's going to do the same sort of operation as ZAcube, so I'll cut the video. I'm going to go badly every time. Sorry, Wouter. It's on my laptop if anyone wants to see it. The next... oh, no, I go back to the... so I'm hopping and blopping here a bit, but... other one? No, thank you. Should have listened. That's just the logo, the launch logo. Notice a spelling mistake, but that's allowable in amateur radio, or typo, I should say. And you can see our logo just here. It's actually the AMSAT one, but here are the flags of all the other people that are launching with us. Here's a couple of shots of the apply before flight port. This is the cable. We didn't go to Yasny. I say we project didn't, but fortunately another employee of ISIS who was on the team, oh God, I can't remember his name. Gerard, thank you. Gerard went to Yasny on another project and was allowed to take our battery charger, which is shown there. We gave the batteries a top up. The thing was dispatched to Russia, fully armed and everything, so we didn't actually have to do anything, but we wanted to check the battery was okay, which we did. There's a little shot of the ABF socket on the bottom of the satellite. You can just see this little bit is the next satellite, which also has an ANTS in. And he came back with this photo and said, yeah, I did put it on, and there's a photo to prove it. That's the actual ABF plug. Sometime before launch, David did a lot of work on where we're going to be, and this is his plot, I think about 2 or 3 weeks before the launch, given the sort of rocket parameters, long and lat and stuff like this, which is, I wouldn't say it's a mystery to me, but he got it pretty well on the nail. And you can see up here is the launch site Yasny in Russia, and it's launched southwards, and we felt it was going to pop out, or David calculated that it would pop out over the of the pod round about here, and after 10 minutes it will be here. Hence the interest in getting people in South Africa to listen. There's a timetable, very approximately. The next thing I wanted to show you was a video which I think's really interesting. This is a simulation of what happens during the launch, and this was given to us by or sent to us by Cosmotraz, and I think gives a very good impression of sort of how it sort of works, if you see what I mean. Rocket coming out of the silo. And you've probably seen videos of those before. And then you'll see stage 1 being ejected or separated, and a bit later on stage 2. And we think that the land underneath this simulation is actually where it was planned to be. I'm going to skip a bit because for some reason that sequence goes on quite a long time. I need to go to about 2 minutes. Okay, this will do. So this is the upper stage just manoeuvring round. I just watch what happens. So there's a fairing ejected. And these are main payloads being ejected. Another bit of the fairing, another main payload, another mini-sat, and then the first 3 CubeSats, which was us. So we're the middle of one of those 3 little blobs coming out. And I think there are a couple of little mini-sats coming out. So I think that gives a very good idea of sort of what happens. I've always sort of wondered, but I can tell you it does work, which is nice. I'm going to skip on a bit now because otherwise I'm going to go over time a bit. In fact, I think I'll go on to one of the things we were interested. I mentioned South Africa. I won't show you those videos. We got this set up at Bletchley Park, where the RSGB has set up their amateur radio visitor centre, and we sort of took over the demonstration there and expanded it quite a bit with some more screens, more computers, and stuff like this. And we all arrived the night before and had a very nervous curry supper, having set it all up and awaiting. And we had a countdown to the launch, which didn't. It was just a time marker for us, really, because we couldn't see it. There wasn't a live feed. There was some audio coming through, but it was rather low quality. But this is just a recording of.
I would actually want to turn everybody down so I can.
Again, I'm going to of what we were doing. So I'm just zooming to get the right.
No extra charge. I was going to try and put that on speaker, and I thought, no,
But if
I'll
we're
kill
doing
the
phone
signal.
calls, we're pretty high up
Dave,
on the
that's
list,
not
which is nice.
something. You're tailing the Apache those things.
What's that going to do?
He's seeing who's looking stuff to the server.
But we're just
So I'm just trying to get the meat. I didn't have time to edit it.
So what we need is somebody when you go on in 2 minutes' time to prove they can get
According to a note here, I can see from Arthur at ISL, the go time was actually 10.147 seconds.
Okay.
So I don't know, that could mean that the kets are less than 1 second slow.
I think we'll say that's good enough.
Yes, good enough.
good enough for government work.
Yes. Thank you.
We're all looking a bit anxious because we're waiting for the first report from South Africa.
Well, if South Africa is listening, they have 1 minute 37 to go.
What, before they hear? Or?
Before they start deployment and restart antenna deployment, and they could hear
we
us.
seem to have lost South Africa or others.
Yeah, because probably Johan ran out to actually go and track it.
Run off outside.
I don't recognise any South Africans on there. Where is Michael?
Is mine not on it?
No.
That's rather unfortunate.
Yeah. It's gone very quiet now.
Yes.
Does this-
Now we wait.
Yeah.
Does this count down to 10
What time it throws
The dongle tube.
This is 10 seconds?
No.
Oh, okay.
So what are we expecting down in keyboard? 45 minutes?
935.
35, isn't it?
How will we know if it has been? Well, this is what we're waiting
So
for.
Dave is probably sitting there watching no data coming in yet.
Except you.
I'm sorry.
Well, it's off
Yes,
now.
could you see that middle screen? That's where it is now, or where it will be?
That's actually not sending data.
Yeah.
So you can see in a half a minute or so, it should start transmitting.
It shouldn't be doing
somewhere in South Africa.
That circle, basically.
Yes, sorry, the little small circle. But then after that goes over to Antarctic, because we haven't got anyone there.
10 seconds until
We have got someone in Hawaii.
10 seconds to what?
boot up.
Boot up. What do you mean deployment? No.
Yes.
We're already booted.
Yeah, ants deployment now.
Should happen.
How long does it take? Any little funnies you put in there, Duncan? Any little Easter eggs?
Not in our flight code.
Not in our flight code.
No, just someone else's.
Well, that's it.
Peter Mendham, who's at FUNcube-2, has just said, congratulations, looks like a good launch. My fingers are still crossed for your first pass. So that's nice that somebody from UQ's is aware of what's going on.
Good.
Watching you on the webcam, says Angela. Hello.
Back of your head.
Yes. Hello. Hello.
Hello.
So now we wait.
So she's obviously just Googled where the hell are they then? That's it. It came up webcam feed, so good one, Ciaran. That obviously works.
So you mean the timeouts of the
So, for those that are not intimately aware, this screen is a warehouse that should be collecting data from receiving stations around the world. We were hoping to have somebody on from South Africa, but there's no evidence that he's there yet. The next station that would hear any signals will be on Hawaii, and then it's really us in Europe, and that's not for another hour, approximately. So what we would see if data is fed into our central warehouse is Dave here jumping up and down because these numbers here are suddenly doing something.
That should go mad.
Yeah, and then for the rest of us who don't understand this gibberish, that time should change. That time is changing. That's weird. And these numbers should change anyway. Because that time.
Yes!
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 Where?
Yes! Yes! We have data.
We have data! 13.7 degrees, our F board, PA board is actually 21 milliwatts power out.
Thank you,
Boss is fine. 21 degrees on the PA device. All data valid. We're getting 409 milliamps.
Thank you!
All the solar panel temperatures are fine. Boss voltage is fine.
Battery voltage?
Battery voltage is 7.84. Total system current 123 milliamps. And the battery is 13 degrees.
Whoa!
Yes!
That could be better. Well, there we go. It just gives you a little flavour of the atmosphere. We had one or two other moments like that which I could show you, but time doesn't permit me. There is a really good one where Graham is trying to destroy a coffee table in his excitement, which I won't embarrass him by showing. So I won't show those other videos. If you see me later, I can obviously play them back to you. But I hope that gives an idea of the atmosphere. We had the first pass at Bletchley Park that we heard. We were a little bit disappointed because it was in safe mode, so low power beacon, and there's quite a lot of noise we found at Bletchley Park, electrical interference, and we decoded a few packets, but not as many as we thought. But the main thing we found was that the battery was significantly colder than we had anticipated, and we had anticipated something like about 5 degrees, but actually about -4, bearing in mind it just come out of eclipse at that time, and that worried us a little bit. And on the next orbit, we decided after that first orbit that it would try and command it into high power mode on the basis that the heat from the PA, or the extra heat from the PA, might warm the battery a bit. And there's another superb video when we blipped the command and it responded immediately to the first command, which was particularly reassuring. That's when Graham was destroying the coffee table. I think probably I better leave it there, otherwise Ciaran's not going to get a fair sort of go. just to say it seems to be going on fine for about 8 months, and we have this schedule now where it's on. Could you put it on the screen? No, okay. Oh, the viewers on TV are watching a live pass, apparently. So there we go. We've had our 1,000,000th packet uploaded to the warehouse, which has happened a few days ago. And the only anomaly we've had is one mysterious reset. We noticed, I've got about 2 or 3 months ago, that it was making a funny noise. And this was reported by some guys in the States. And we just did like a master reset, and it came good. So we just put that down to a cosmic thing or something like that. Ciaran, I'm sorry I've overrun. So I'll leave the story to you. I'm around if you've got questions or want to see more of the videos during the weekend. Thank you very much. I'm sorry?
What's the life expectancy?
We think, well, the orbit is good for 30 years. We think the first failure is going to be the battery, maybe 5 years or so. But we designed the spacecraft specifically that when the battery fails, it will still work when it's in sunlight. So it could go on for a long time. We hope.
Many years.
Sorry?
Many years.
Many years, hopefully, yes.
Okay, there's a couple of things I'm going to talk about briefly, but the first one that I want to do very quickly, and it's not quite as elaborate as Howard's demonstration that he did a year or two ago, but we are very pleased to announce that we have just released, as you can hopefully see there, the latest version of the dashboard and guidance notes that go with it. This particular version of the dashboard has got very vastly improved telemetry, tuning and tracking mechanisms in it as well, and has been under test by most of the team for quite a while. So we're very pleased to announce it, and hopefully that is now public and everybody can join in and download it and give us some feedback in terms of the performance of it. Now, if I can just find my presentation. One of the things that we wanted to do with FUNcube was to try and make sure that we got into the classrooms sort of doing educational outreach in some way, shape or form. Now, for people involved with science, technology and whatever, this is usually a somewhat difficult thing to do, because it can sometimes be very difficult to try and pitch the actual activity itself. The reference, this is just another picture. You can see sort of Graham with a worried face and the amounts of hands in the air that happened at the moment of launch. And the first frame of data that actually came in from South Africa. The key thing with FUNcube was that we wanted to do something with outreach. We wanted to try and not just make this a one-off amateur radio transponder or whatever. So one of the key things that we had was something that we termed the material science experiment. So these are the black panels that you can see and the silver strips as well. And at the bottom you can also hopefully just make out some black strips as well. And on these we record the temperatures, both warming up and cooling down as it goes into eclipse and comes out of it. The dashboard that everybody hopefully has got a hold of now, as you can see, actually allows us to take all of this information and see what's there. And the big challenge for us is, what can we do with it? How can we actually use it? And how can we inspire kids to actually deal with it? One quick win that we have is the fitter messages, and I think hopefully everybody is fairly familiar with some of the capabilities on the messages, and we've certainly done some sort of STEM outreach and provided a specific message for the people that we were actually meeting. Oh, wow, okay. Sorry, I've just been given a 10-minute warning. We have that capability, and I can report that I've actually done some outreach in a school where I had a group of under 10-year-olds just holding a Surface tablet computer with one of the cross-dipole antennas standing in a field. They recorded the data, and a message came down that was specifically addressed to them. And the look on their faces at that point was something to be remembered. I'm going to whiz past on the dashboard, but the new version, very, very briefly, not only has it got the better tuning and the better tracking mechanisms, there's a couple of extra features. We've now enabled the bias T function for the FUNcube dongle, so you're able to switch that on if you're using a masthead preamp. And if you set any limits on the auto-tune range, these limits will be remembered across versions of the program starting up and shutting down. So, whizzing past all of these, we've seen some of these. This is a very simple graph that is of the telemeter data of the silver panel, for example, as it's warming up and effectively getting to a thermal equilibrium itself before it goes into eclipse and then decays. So the big job that we've had is, how can we use all this? How can we demonstrate this and make it relevant? Going back to the satellite itself, we've got the black panel as well. And the idea behind this was the good old-fashioned Leslie's cube experiment, the heat loss or heat radiated from an object in a vacuum. Somewhat difficult to do on Earth, but we've got something here that potentially could do it. And we're always looking for help and assistance from science teachers or interested parties to try and really work this up and use it. And I know, and I've forgotten his name, NHM, Mark, across in the States, has done a wonderful job on some of the outreach stuff that he's published so far on it. But we're looking to sort of try and keep on developing it. So, using FUNcube in the classroom, very difficult to pitch depending on which classroom you're looking at. Very simply, we've sort of tried to break it into two, what we term Key Stage 2, Key Stage 1, Key Stage 2 primary school children in the UK, and Key Stage 3, Key Stage 4 secondary school kids. Some of the examples that have been worked up by members of the team are very simple, keeping a track of the total panel current being produced while it's in the sun. Each one of the dots represents a reading every minute. So we're able to get kids looking at graphs, interpreting them, taking data out of graphs, working out how long a whole orbit is, and then actually giving them a real-life example of, well, you know, what's the importance of the equation 2 pi r? Why would I want to know it? Well, in a very simple sense, we can talk about the distance travelled by the satellite being in an idealized world just a pure circle around the Earth. If we know how long it takes to do one complete lap and they can work out the distance that it's travelled, then we can start talking about velocity and speed. And when you start talking then about the 7.5 kilometres per second that it's travelling at, you can start to engage in a little bit of talk with them about it. Likewise, trying to explain the difference between the light-coloured and the dark-coloured surfaces, we can actually start talking about, well, why are properties in sort of around the Mediterranean painted white or coloured white? Why don't you colour them black? And you can actually engage them in sort of relating to real physical things that are actually demonstrated by the satellite. But it doesn't end there. We've also got the ability to look at magnetic fields in space. As the satellite orbits, its position will change. Very much like the good old experiment that you do with a bar magnet and some iron filings on a piece of paper and lots of little compasses. So how can we use the satellite to sort of replicate that type of experiment? Going into the secondary school, so these are coming up to the public examinations for children in the UK. What we're wanting to do is sort of not just limit it to good old STEM type subjects, but actually take it across the breadth. And how can we use it in there? We've been working on, or at least we've been trying to work on things like how can we get it into the English type criteria, where it's all about describing things, talking about things, but also history. Quite a few raised faces every time we do that, but then when we come to talk about the fact that most of the space industry today has arisen out of the Cold War, and the rocket that we used was actually originally pointed at one of us with nuclear bombs on it. So there's something there that we can sort of try and engage people with as well. Going into the physics side of things, we have lots of information about what is an orbit, how do you get into orbit. It's very apt at the minute that Tim Peake has just named his mission Principia after Isaac Newton, and of course there's all the stuff about Newton's Newtonian canon that you can start talking about. Why do you stay in orbit? What are you actually doing when you're in orbit itself? We've also sort of able to start introducing things like what type of orbits are useful for certain things. For example, the polar orbits tend to be the ones that the weather satellites are in. So we can then start to try and link weather satellites to geography and getting them to download the live data as well. We can also go on and start talking about electromagnetic spectrum, communications, alternative energy sources, because of course you can then start talking about, well, solar panels and batteries and how do you power the satellite. We've got the very standard mathematics side of things, sort of how just all the mathematics about what's going on there, orbit prediction, everything as well. And going into history and the geography side of things as well. So the key thing that we're looking to try and do is find the ways that we can actually get the concept of FUNcube in, get it to stimulate the STEM type activities, but also across the breadth into the other subjects, but do it in a way that actually inspires the kids to want to do something with radio, with science, with technology as a future career. Massive task, and by any means, anybody that has tried it knows that it is not the simplest thing to actually do. So we're always looking for help. We're always looking for people to come and join us and help us with these particular areas. Because the curriculum these days is very particular on certain things, and it's how do we tie all of this in. That's the example of the thing. And just to show, we've got different exam boards in the UK. So we've got similar sort of topics coming across the different exam boards. So it's things that we can sort of develop once and potentially use for many different examination systems in the UK. And that's sort of it, hopefully within about a minute or so. So very, very rough and fast run through. But like I said, we're always looking for help and assistance. The STEM outreach is one of the key goals of the project itself, and we're always looking to sort of make sure we can plug that wherever and whenever we can.
Okay, Ciaran, thank you very much indeed. I think as we are right up against the deadline on time for our next speaker, we'll just have perhaps one question while Ciaran's sorting out the laptop there. So all of the FUNcube team, of course, are around the building for the next couple of days. If you have any specific questions you want to ask any of them, please do so. Is there anyone who has any thoughts that they would like to share with us or ask a question right now? No? OK, that's probably not a bad thing. In which case, I'll say thank you very much to Ciaran and Jim for that synopsis, a quick bit of history on FUNcube over the last... Indeed, over the past 8 months. And perhaps invite our next speaker to come to the front.